Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on linear algebra chapter minimal polynomial and minimal equation of a matrix, lecture number 8, in which I will solve some more problems of this chapter. Now we solve a problem. Problem is, if A and B be n by n matrices and B be non-singular, then show that A and B inverse AB have same minimal polynomial. Now we solve this. Solution: given that A and B are two n by n matrices, means size of A and B be same, they are of n by n matrices, in which B is non-singular. Implies that B inverse exists. Let fx equal to x to the power r plus a1 x to the power r minus 1 plus a2 x to the power r minus 2 plus plus a r minus 1 x plus ar be a polynomial that annihilates matrix A. Therefore, function of A equal to a to the power r plus a1 a to the power r minus 1 plus a2 a to the power r minus 2 plus plus a r minus 1 a plus a r, multiply 1 here. In place of 1 we write unit matrix equal to 0 matrix. Let this is number 1, this is number 2. Now B inverse AB whole square equal to B inverse AB multiply B inverse AB equal to B inverse A B inverse AB. This equal to B inverse A B inverse is unit matrix I AB. This equal to B inverse A square B, because A multiply unit matrix is A multiply A is A square. Now B inverse A B whole cube equal to B inverse AB whole square multiply B inverse AB equal to, this is equal to B inverse A square B multiply B inverse AB. This equal to B inverse A square. Here we B inverse B inverse AB equal to B inverse A square. This is unit matrix. B inverse is unit matrix. A B. This is equal to B inverse A square multiply unit matrix is A square, and A square multiply A equal to A cube B. Similarly, B inverse AB whole to the power k equal to B inverse A to the power k B. K is a positive integer. This is number 3. Therefore, if B inverse AB equal to, in place of x we have B inverse AB. We write here B inverse AB whole to the power r plus A1 B inverse AB whole to the power r minus 1 plus plus A r minus 1 B inverse AB plus AR multiply B inverse, in place of unit matrix we may write B inverse B inverse unit matrix I into B. This equal to B inverse A to the power R B plus A1 B inverse A to the power R minus 1 B plus plus A R minus 1 B inverse AB plus AR B inverse IB implies that if B inverse AB equal to, we write B inverse under bracket we write A to the power R here plus A1 plus A1, we have taken B inverse outside, A to the power R minus 1 plus plus A R minus 1 A plus AR here I, and we write here B. Here B inverse A to the power RB, we get B inverse A to the power R multiply B, then A1 B inverse A1 B inverse A to the power R minus 1 multiply B, and in this way we get other terms, and we get here B inverse, this is FA B from 2. This is number 4. here we get that if B inverse AB equal to 0 matrix, if and only if FA equal to 0 matrix, FA equal to 0 matrix, then right side 0, then left side equal to 0. Therefore, Fx annihilates the matrix B inverse AB if and only if Fx annihilates the matrix A. If Fx is minimal polynomial of matrix A, that is Fx is the lowest degree monic polynomial that annihilates A, then Fx will be minimal polynomial of matrix B inverse AB, and conversely proved. Therefore, we may conclude that the matrix A and the matrix B inverse AB have same minimal polynomial. Now we solve the next problem. Next problem is, let A be an idempotent square matrix, then eigenvalues of A are equal to 1 or 0. If A is not 0 matrix and A is not unit matrix, then minimal polynomial of A is lambda square minus lambda. Now we prove this. Given that A is an idempotent square matrix, therefore A square equal to A implies that A square minus A equal to 0 matrix. Let this is number 1. Let F lambda equal to lambda square minus lambda implies that FA equal to A square minus A, and by using 1 we get 0 matrix. Let this is number 2. This is number 3. Therefore, F lambda annihilates the matrix A. Let M lambda be the minimal polynomial of matrix A. Therefore, M lambda divides F lambda, implies that M lambda divides F lambda is lambda square minus lambda, implies that M lambda divides, we take common lambda, lambda minus 1, implies that M lambda equal to lambda or M lambda equal to lambda minus 1 or M lambda equal to lambda multiply lambda minus 1. Let this is number 4, this is number 5, this is number 6. If M lambda equal to lambda, implies that MA equal to A. This is number 7. Since M lambda is minimal polynomial of matrix A, implies that MA equal to 0 matrix, implies that MA equal to A here, A equal to 0 matrix. Therefore, each characteristic root of A will be 0, implies that lambda equal to 0, because we know that each characteristic root of a 0 matrix be 0. This is number 8. From 5 we get MA equal to A minus, in place of 1 we write unit matrix I, implies that minimal polynomial. So MA equal to 0 matrix equal to A minus I, implies that A equal to unit matrix. We know that the characteristic roots of unit matrix be 1. Therefore, each characteristic root of A will be 1. Therefore, lambda equal to 1. This is number 9. From 6 we get that lambda equal to 0 or lambda equal to 1 be roots of m lambda, m lambda be the minimal polynomial of matrix A, since each root of minimal polynomial be characteristic roots of the matrix. Therefore, lambda equal to 0 or lambda equal to 1. This is number 10 from 8, 9 and 10. We get that characteristic roots of an idempotent matrix A will be 0 or 1. If A equal to 0 matrix, then minimal polynomial m lambda equal to lambda from 4, and it satisfies A square equal to A. Again, if A is unit matrix, then minimal polynomial m lambda equal to lambda minus 1 from 5, and A square minus A equal to I square minus I equal to I minus I equal to 0 matrix. Implies that A square minus A equal to 0 matrix implies that A square equal to A. But if A not equal to 0 matrix, A not equal to I, then from 6 we get the minimal polynomial of A m lambda equal to lambda multiply lambda minus 1 equal to lambda square minus lambda, and problem solved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button, and if you have not yet subscribed my YouTube channel, then please subscribe my YouTube channel. Thank you.